Welcome to the Sabre RD online training course. This series of fast-paced videos will teach you the full power of the Sabre RD simulation environment. In this section, we explore fault analysis. Functional safety. If a system fails, it must do so in a safe, predictable manner. ISO 26262 is the most prevalent functional safety standard for electrical and electronic systems within road vehicles. It recommends simulation for system and hardware level verification. Sabre's fault simulation and automation are ISO 26262 certified, with an approach that is faster and more comprehensive than manual fault tracing methods. Sabre's fault simulation systematically tests how a system responds to a wide spectrum of fault conditions. Experiments automate the process. Multi-core processing utilizes all computation resources to slash simulation time. A tabulated report identifies system failures. Let's see how Sabre FS works by going through a switching power supply example. Our safety goal is to ensure the power supply's output voltage will not harm other systems if any of its components fail. We cannot let the output voltage exceed 30 volts or go below -1 volt in the event of failure. First, we create a set of faults by opening the Faults tab and pinning it for visibility. The simplest way to define a fault is to select one or more components and press the green plus button. We get a choice of fault types, opens, shorts, and parameter variations. Default values are added for non-fault and fault conditions. Instead of adding component faults one by one, we can select the Generate function to create a comprehensive list. For our example, we choose opens and shorts for the components while skipping parameter faults. Starting with this list, we simply delete unnecessary faults. The data columns include the initial value, the fault value, at what time in the simulation the fault will occur, and when it will return to its initial value. We can change any of these settings to meet our purposes. The table can be exported to a tab-separated list, enabling editing in a spreadsheet such as Excel, after which it can be imported and validated. To create concurrent fault combinations, we Control-click two or more faults from the list, and then the green plus sign in the concurrent fault group area. The most direct way to run a fault analysis is from the Simulation tab. With the looping pull-down, we select Fault. However, we can automate fault simulation with an experiment. There's a Sabre training video dedicated to creating experiments. You may wish to review that video first. We select the Experiment tab, create a new experiment, give it an identifier name, and click OK. First, we add a reference transient analysis with no faults using an end time of 40 milliseconds. Selecting the Fault button adds it to our experiment. Clicking on the question mark prompts us to choose our fault list. In the Properties pane, we choose Multicore from the Loops pull-down and set the parallel runs to 4 to utilize all the physical computer cores for the simulations. We choose Transient again to place a simulation inside the fault analysis loop, again setting time end to 40 milliseconds. Clicking on the Measure button places it inside the fault analysis loop. We click on the question mark to select the DC out waveform from the TR2 analysis. We change the measurement type by clicking on the @x variable. The maximum measurement is found in the Levels category. In the Properties pane, we give it a different name. We create another measure, but this time using the minimum. Pressing the Test button adds it to the fault loop. We click on the question mark and type in a Boolean expression which says measurements under 30 volts are acceptable. This implies measurements over 30 volts are a failure. We specify another test to check for faults which produce negative output voltages below -1 volt. We could use just one measure with a Boolean expression to test both conditions, but then we will be unable to determine which condition causes the failure. To see the waveforms corresponding to each fault, we create a graph container. This container has two signals. The first is the no-fault transient analysis. The second is the family of signals for all the injected faults. Everything is set. It's time to simulate. We go to the Simulation tab, choose Experiment from the pull-down menu, select the experiment we just created, and launch the fault analysis. The analysis produces a report and a set of plots. One plot is for the no-fault simulation. The other one displays the fault simulations. Member Attributes lets us highlight any of the fault curves. The experiment report is a table summary of all the fault simulations. Expanding the fault list shows which have failed and which test they failed. The report can be exported to an Excel spreadsheet for further processing. Sabre offers a variety of capabilities to develop and validate safety mechanisms with state AMS, hardware description languages, support for C-code and functional mock-up units, and co-simulations. We can also define parametric faults, letting us degrade components or change their performance characteristics. For example, we can observe the effects of a filter capacitor losing most of its value, monitor amplifier performance if the gain of an op-amp deteriorates, or see the impact of software faults on a controller by changing its clock frequency. We can create multiple fault sets by using the Copy Set button and editing. Multiple fault tasks in our experiment can reference these extra sets. Running the experiment puts results into a single hierarchical report, which we can export to an Excel spreadsheet for further analysis. This concludes this section of the Sabre RD online training course. To download a free student version of Sabre RD, go to the Synopsys website. To further your understanding of this material, go through the lab exercises found at the link listed in the description of this video.